Welcome to the Deep Dive. We're tackling Ethereum today. I think most people have at least heard of it by now.
Yeah, for sure.
And, maybe know some of the challenges it's faced, like how much energy it uses and just how many transactions it can handle at once. That kind of bottleneck thing.
Yeah.
But you're here because you want to get up to speed on everything that's been happening, all the big changes, right? And you want to make sure that understanding is, really solid, nothing left out.
Exactly.
That's what we're going for today.
We've got a great set of sources for this one.
Yeah.
We're diving into the technical details of those layer 2 scaling solutions. Those are becoming really important. Plus, we've got an in-depth report on the Ethereum Merge that was huge.
Right.
And we're looking at some discussions about the future of Ethereum, where it's headed next, all the upgrades that are coming down the line.
Okay, so our mission today is to cut through all that noise and give you the core insights from all of that stuff. So we want you to walk away really understanding how Ethereum has changed, like fundamentally.
Yeah.
And where it's going next. We're not going to get lost in any technical rabbit holes.
Nope.
Just the essentials, presented in a way that respects your time, because we know you're busy.
Absolutely.
All right, so let's unpack this.
Let's start with what's probably the biggest turning point for Ethereum, the merge.
Oh.
This wasn't just some minor tweak. It was a fundamental change to how the whole network works.
Okay.
It happened on September 15th, 2022, and it marked the switch from a proof-of-work system to proof-of-stake.
And just for anyone who needs a refresher, that means we changed how transactions are checked to make sure they're legit and how new blocks are added to the blockchain. We got rid of all that crazy energy use from mining.
Exactly. And there were two main reasons for this huge change. First, we needed to drastically cut down Ethereum's energy use. I mean, it was a big concern for environmentalists and regulators, everybody, really.
Right.
But just as important, the merge laid the groundwork for future upgrades to make the network way more scalable, so it can handle way more transactions.
So this wasn't just about going green. It was also about building a foundation for Ethereum to actually grow and be used by way more people.
Absolutely. This shift completely changes the conversation about whether blockchain can ever be truly sustainable. It might even be what opens the door to wider adoption by, big institutions and governments and all that.
And when we say drastically cut down on energy, the numbers were pretty mind-blowing, weren't they?
Oh, yeah. According to Decentralized, the merge cut Ethereum's energy consumption by, get this, almost 99.98%. To put that into perspective, before the merge back in May 2022, we're talking something like 93 terawatt hours per year, maybe as low as 19. But after the merge by October 2022, it was down to something like 0.00096 terawatt hours, maybe as low as 0.00249.
So basically nothing.
Pretty much.
I mean, before the merge, it was using as much energy as some entire countries. So how did they pull off such a radical change? What's the difference between proof of work and proof of stake?
Okay, so proof of work, that's what Bitcoin uses, right? It relies on miners using tons of computing power to solve these really complex math problems. Right. It's this whole energy-intensive race, and that's how they confirm transactions and get to add new blocks to the chain. Proof of stake is totally different. Instead of miners, you've got validators. They put up some of their own ETH as collateral. It's like a security deposit.
I see.
Then the network randomly picks a validator to propose a new block, and a bunch of other validators check it to make sure it's legit. This picking process uses something called RANDO, which is how they get that randomness on the blockchain.
So no more crazy energy use trying to solve those math problems.
Exactly. Plus, with proof of stake, they've got this fixed rhythm for making blocks. Time is split into 12-second slots and 32-slot epochs. Every slot, they pick a validator to propose a block and a group to verify it. This steady pace is a big difference from the less predictable block times we had with proof of work.
Interesting. So the main goal was to cut energy use. But did the merge change anything else about the network?
Yeah, actually. The reports we looked at said the average time to make a block went down to about 12 seconds after the merge.
Oh, okay.
Doesn't seem like much, but that actually made the network about 13% faster at processing blocks. But the really big leaps in how many transactions it can handle, that's going to come from those layer 2 solutions.
So it's like a nice little bonus on top of the energy savings. What about for people who actually use Ethereum? Did they have to do anything differently after the merge? I remember there was a lot of talk about whether people would need to swap their ETH or something.
That's a really good point. They designed the merge to be super smooth for regular users. You didn't have to do anything with your ETH. The whole history of the blockchain, all the way back to the beginning, stayed the same.
Okay, good.
And all the transactions and smart contracts, they kept working just like before. All the big changes happen behind the scenes in how they validate transactions.
Gotcha. That makes sense. But what about all those Ethereum miners? Their whole business was based on mining, and then suddenly it was gone. What happened to them?
Yeah, the merge definitely had a big impact on miners. All those specialized computers they had, especially those ASICs made just for Ethereum mining, they were basically useless on the main network.
Right.
A lot of them had to look for other blockchains to mine. And we did see a pretty big jump in the computing power on other proof-of-work chains, like Ethereum Classic, Ravencoin, and Litecoin, right after the merge.
Oh, okay.
That's a pretty strong sign that a lot of miners moved over to those chains to keep earning rewards.
So Ethereum got greener, but maybe some of that energy use just shifted to other places? Is something to think about, for sure.
All right, so the merge was this huge change. It really set the stage for everything else. But like we said earlier, scalability is still a big challenge. It needs to be able to handle way more transactions faster and cheaper. And that's where these layer 2 solutions come in, right?
Exactly. The merge was essential, but it didn't magically solve all the scaling problems. That's where layer 2 tech comes in.
They work on top of the main Ethereum network. We call that layer 1 to boost the transaction capacity and bring those fees way down.
So they're kind of like helpers, taking some of the load off the main chain.
Right. Think of them as express lanes that keep things moving faster. Our sources talk about two main types, optimistic rollups and ZK rollups.
Right. Okay, let's start with optimistic rollups. How do they make things faster and cheaper?
Well, they handle transactions off-chain, meaning separate from the main Ethereum blockchain. Then they bunch a whole lot of these transactions together, that's the rollup part, and send a summary of the changes back to Ethereum as one transaction. And the optimistic bit, they basically assume all those off-chain transactions are good to go.
So they're optimistic about things going smoothly.
Exactly. But of course, you need a way to deal with those just-in-case moments. What if some transactions are actually bad? Like fraudulent or something?
That's a good point. What happens then?
Well, they've got something called a challenge period, usually about a week. During that time, if someone thinks there's fraud in the batch, they can submit a fraud proof to Ethereum. And if they're right, the bad transaction gets reversed, and the sequencer, that's the one who bundled the transactions, they might get penalized.
That makes sense. But that week-long, wait, doesn't that seem like a long time for people who need to use their funds right away? Are there situations where that could be a real problem?
Yeah, you're right. For time-sensitive stuff, or if you need to access your funds immediately, that delay could be a real pain.
Right.
Our sources mention a few big players in this space, like Arbitrum and Optimism.
Okay, what do we know about those?
Fill us in.
So Arbitrum has this product called Arbitrum Rollup, and it's basically a whole set of tools for scaling Ethereum. It's designed to feel just like using Ethereum directly. You can run those Web3 apps and deploy smart contracts, but with much lower costs and faster speeds. And a big plus is that Arbitrum Rollup inherits Ethereum's security measures. And they've got their own token, ARB.
What about Optimism?
Yeah, they're another big one. Their main product is Oki Mainnet, and it's built by Ethereum devs, specifically for Ethereum devs. It's another layer 2 blockchain using optimistic rollups, and it's all about speed and low costs. They've really focused on EVM equivalence, meaning it's compatible with the Ethereum virtual machine, the environment where all those smart contracts run. So you can easily move apps from Ethereum to OP Mainnet and save a ton on gas fees. Interestingly, our sources didn't mention a specific token for Optimism, at least not in this overview. We also saw Metis Andromeda and Boba Network mentioned as other optimistic rollup solutions. Boba Network even offers a liquidity provider service to speed up withdrawals, which, we were just talking about how that could be a bottleneck.
That's a nice feature. So besides the wait for withdrawals, are there any other downsides to optimistic rollups we should keep in mind?
Yeah, a couple things. Their security really depends on those financial penalties for bad actors.
Right.
And to be transparent and let anyone challenge potential fraud, optimistic rollups usually publish all the transaction data on Ethereum as call data. It's basically public data attached to the transaction. That's good for transparency, but it can mean higher costs on layer 1, although it's still way cheaper than using Ethereum directly.
Okay, that makes sense. So we've covered the optimistic approach. Now, let's dive into those ZK rollups, zero-knowledge rollups. They sound a bit more, complex. How do they handle scaling?
ZK rollups are totally different. Instead of just assuming everything's valid, they create this cryptographic proof for each batch of off-chain transactions. It's called a validity proof or a zero-knowledge proof. Basically, it's math that guarantees those transactions were done correctly, no funny business.
So instead of waiting to see if someone cries foul, they've got this mathematical proof that says these transactions are legit.
Exactly, and that's a big deal. Because of those proofs, transactions on ZK rollups are considered final as soon as Ethereum verifies the proof. No more waiting around for challenges. And that also means way faster withdrawals than with optimistic rollups.
Much faster. Okay, so what else is good about this approach?
Well, they don't have to publish all the transaction details on Ethereum because the proof itself basically guarantees everything's accurate. That can lead to better data compression and potentially even lower costs on layer 1 down the line. And the security of ZK rollups, that's all based on these really strong cryptographic guarantees.
Okay, so they're fast, they're secure. What are the downsides? This sounds almost too good to be true.
Well, historically, one issue has been that ZK rollups weren't as good at handling complex smart contracts compared to optimistic rollups, but that's changing quickly with new EVM-compatible ZK rollups.
Right.
Also, creating and checking those zero-knowledge proofs, that takes a lot of computing power. You need specialized hardware, and it can be expensive. And that can also lead to higher costs for each batch of transactions.
Yeah.
Our sources mentioned Polygon ZK EVM and Polygon CDK.
Right.
That's Polygon using ZK tech for scaling.
Okay.
And they're aiming for full EVM compatibility there. We also saw Scroll, a scaling solution focused on security, also using ZK proofs. So if your priority is finalizing transactions as fast as possible, then ZK rollups are the way to go. But for compatibility with what's already out there on Ethereum, optimistic rollups might be a better choice, at least for now.
Right. Now, what about Polygon? Our sources talked about it being a bigger, more comprehensive scaling solution for Ethereum, not just using rollups.
Yeah, Polygon's a whole suite of solutions, not just rollups. They even have their own blockchain, a sidechain, and they're increasingly using those ZK rollups too. It's a platform for faster and cheaper transactions with lots of different tools for devs who want to build user-friendly dApps.
Okay. I also noticed a mention of a token change from Matic to Pull. What's that all about?
Yeah, Polygon is switching things up as part of their Polygon 2.0 upgrade. They're moving from their old Matic token to a new one called PO. It's a gradual process, and both tokens are still around for now.
Right.
But the idea is that POL will be better for supporting multiple blockchains, and it'll improve how the Polygon ecosystem is governed. Plus, it'll open up more staking opportunities.
So it's an upgrade to match their bigger ambitions.
Exactly. And it's a key part of their AG layer, which is all about making different blockchains work together seamlessly. Matic was mostly for the original Polygon network, but POL is designed to be the main token for all of Polygon 2.0.
Cool. So how does Polygon's transaction processing compare to Ethereum's?
Right now, Ethereum averages about 15 transactions per second, but Polygon's POS chain handles around 42, so it's quite a bit faster.
Right.
That makes it much more appealing for a lot of devs and users who want lower fees and faster speeds.
Makes sense. So it's not just about speed, it's about building a whole ecosystem that works with and improves on Ethereum.
Exactly. They've got Polygon POS, their work on ZK Tech with Polygon ZK EVM and the CDK, and they're developing the Polygon AG layer for cross-chain interoperability. It's really a comprehensive toolkit for scaling Ethereum. Our sources also mention Teen,
Right, CD.
the modular interoperability layer. It just shows how important it's becoming to connect different blockchains smoothly.
So it's clear that scaling Ethereum is a huge ongoing project. We talked about the big shift of the merge and all these crucial layer 2 solutions. But what's next for Ethereum itself? What's on the roadmap after all these immediate changes?
Right. The journey started with the Beacon chain back in December 2020 and ended with the merge in September 2022. That's what people were calling ETH 2.0, though that term isn't used so much anymore.
Right.
But that was really just the beginning.
Right.
Ethereum's got a whole roadmap for what's coming next, several big stages beyond the merge.
Okay, let's break those down. We saw names like the Surge, the Scourge, the Verge, the Purge, and the Splurge. What's the main focus of each one?
The Surge is all about scaling up even more, mostly through those roll-up technologies we were talking about and EIP 4844.
Right.
That's designed to give rollups way more data to work with. The goal is to get to a crazy 100,000 transactions per second across the whole Ethereum ecosystem.
100,000 transactions per second. I mean, that's not just a performance boost.
All right.
That could enable totally new kinds of dApps, things you can't even imagine right now.
Exactly. And then we've got the Scourge. That one's about reducing the risk of economic centralization in the network.
Okay.
And making things better for managing validator nodes and the whole process of verifying blocks. Then there's the Verge.
The Verge. And what's that about?
That's focused on making block verification more efficient, but without raising the gas limits on layer 1. They're looking into advanced cryptography, stuff like Merkle trees.
Yeah.
It's a more efficient way to represent the blockchain state. And that could mean smaller proof sizes, so nodes can work better and the network can handle even more.
And then we've got the purge. It sounds like they're cleaning house.
Yeah, the purge is all about simplifying the Ethereum protocol. They'll be getting rid of old data and basically cleaning up the code. And that should make it easier to run a node because you'll need less resources.
And finally, we've got the splurge. What's that about?
The splurge is less about specific changes and more about ongoing development.
Okay.
Things like growing the ecosystem and getting more people involved in the Ethereum community.
So it's an ongoing cycle of upgrades and improvements. And there are some specific upgrades coming up soon, like Pectra in COM25. What can we expect from that one?
Pectra should be here in 2025, and it's all about making validators work better and giving smart contracts more functionality. So the platform will be even more powerful for devs.
And they also mentioned social recovery for wallets. That sounds like it could be a big deal for user experience and security.
Definitely. It's a much-needed feature. Right now, people rely on seed phrases to recover their accounts, and those are not exactly user-friendly. With social recovery, you can choose some trusted contacts as guardians. If you lose your private keys or they get compromised, your guardians can help you get back into your wallet.
Makes sense. Much easier than trying to remember that long seed phrase.
Exactly. It's a big step toward making crypto more accessible for everyone. And then there's this idea of native rollups. It's still in the research phase, but it sounds interesting.
Native rollups, yeah?
They're looking at the possibility of making EVM verification, that's the Ethereum virtual machine, like a built-in part of Ethereum itself.
So building it right into the core.
Exactly. And that could lead to even tighter integration and better efficiency for layer 2 solutions down the line.
It's amazing how much innovation is happening around Ethereum. Now, one of our sources used this WISE ecosystem as an example of how all this tech is being used in the real world. Can you tell us a bit more about what that is and how it fits into the bigger picture of Ethereum?
So the WISE ecosystem is all about decentralized finance, or DeFi, and it's designed to generate revenue. It's built on Ethereum and a few other blockchains. Okay.
They have different protocols, some for liquid NFTs and some for lending and borrowing.
Right.
It's a good example of a trend we're seeing. People are taking advantage of Ethereum security while building these really complex systems for sharing revenue. And the fact that WISE is on multiple chains shows how important it is for different DeFi platforms to be able to work together.
And there's this OWL DAO at the heart of it all, right?
Yeah. The OWL DAO, or Decentralized Autonomous Organization, that's the governance structure for the whole WISE ecosystem. It takes the revenue from all those different WISE protocols and then allocates it across 5 main areas.
5 main areas. Okay.
It rewards people who stake WISE tokens. Then there's strategically buying and burning WISE tokens,
Okay.
potentially to, control the supply.
Makes sense.
Then they provide funding through grants for new projects that want to build on WISE. They manage the DAO's treasury through different asset management strategies.
Okay.
And they also have a VIP program to reward long-term or big contributors. So it's designed to encourage people to participate and help the ecosystem grow. Makes sense. They also mentioned something called Liquidity 2.0. What's that about?
Liquidity 2.0 is their new way of providing and managing liquidity. Instead of just using the usual liquidity pools that pair their token with Ethereum, this model lets new projects pair their own tokens directly with WISE to get started. And the cool thing is that projects can access something like 50% of the capital they raise right away. WISE even offers a whole token launch package to other protocols that want to use this model.
A token launch package. What's in that?
It includes things like smart contracts for a fair launch auction, the Liquidity 2.0 structure itself, dev support for a Web3 interface, and even some strategic consulting.
So it's like a one-stop shop for launching a new token on their platform.
Exactly. And WISE isn't just on Ethereum. They've got a multi-chain strategy.
Right.
They're already on Ethereum, Binance Smart Chain, and Casper, and they're planning to expand to Polygon, Harmony, Solana, and Avalanche. They'll use bridges for their ERC20 token to make that happen. And get this, they're going to pool the revenue from Ethereum and its layer 2 EVM-compatible chains like Polygon and use that to reward people who stake their tokens.
So they're incentivizing staking on those layer 2s.
Exactly. They want to encourage people to use platforms like Polygon where fees are way lower. It's a smart strategy, really taking advantage of those layer 2 benefits.
It's a great illustration of how projects can build on Ethereum's strengths while using layer 2s to make things better for users. All right, we've covered a lot today.
Yeah.
The big changes from the merge, those essential Layer 2 scaling solutions, the future roadmap for Ethereum, and even a real-world example with the WISE ecosystem. What are the key takeaways you'd want our listeners to remember?
The most important things to remember are, first, the merge basically eliminated Ethereum's massive energy use. That was a huge achievement. Second, all those Layer 2 solutions we talked about, they're crucial for making Ethereum scalable enough for widespread adoption. And it's really important to understand the differences between things like optimistic rollups and ZK rollups.
Right.
And finally, Ethereum is constantly evolving. They've got a clear roadmap for future upgrades to make it even more scalable, secure, and efficient, and just better for everyone.
And for you, our listener, we hope this deep dive gave you the clear, concise understanding you were looking for. These fundamental changes, the move to proof of stake and all the progress in Layer 2 scaling, they're key to understanding the future of blockchain tech, especially for Ethereum.
So this brings up a big question for you to think about. Now that the merge has dramatically reduced Ethereum's energy use and Layer 2 solutions have the potential to bring fees way down and speed things up, what new possibilities do you see for blockchain tech? How will this affect adoption in the real world?
It's something to ponder, for sure. As Ethereum keeps evolving, how will this balance between the security of Layer 1 and the scalability of Layer 2 shape the future of decentralized systems and the impact on society? There's so much to explore here. We encourage you to dig deeper into those Layer 2 solutions or check out that detailed Ethereum roadmap. See what catches your interest. Thanks for joining us on this deep dive.